Welcome back to All This Math. This is Professor Parker. And for this lesson, we're going to get into some statistics. And everybody hates statistics, but statistics really not that bad. And statistics are very important. Out of all the different branches and areas of mathematics, statistics might be among the most, I'm not going to say important because all areas of mathematics are important, but it might be the most practical, I should say, to everyday, the mundane realities of everyday life and the things we see right around us in front of our face, right? In terms of understanding them and being able to interpret them. Because a lot of times news media is using statistics, corporations are using statistics, advertisers are using statistics. And one of the things you want to do is to be able to tell if these people are even telling the truth or if they capping, right? You want to be able to know. Because if you don't know the math, you don't know the stats, they could be lying right to your face and you won't even know it. You don't want to be in that position. That's not a good look at all, right? So we're going to get into a frequency distribution table, right? That's what this is. Frequency, we're dealing with weights of people, right? We got weight ranges from 120 pounds to 139 pounds, 140 pounds to 159 pounds, 160 to 179, 180 to 199, and 200 to 220. This column is for our frequency, meaning how many individuals have a weight in this range, and so forth. This column is going to be for the cumulative frequency. This column is going to be for the midpoint of the ranges, and we use that to figure out the mean. This column is for the product of the frequencies and their midpoint of the ranges, right? We also use that to figure out the mean. And so we're going to get into all of this. Here's the formula for the mean already written down here. Here is the formula for the midpoint, which is written up here. Lower plus upper divided by 2. And the median, we use the sum of the frequencies divided by 2. We take that number in terms of the numerical position, and we find out what range it's in using the cumulative frequency. We're going to get into all that in one moment. But first, since I got my Burkinabe Revolution, Thomas Sankara, rest in peace to Thomas Sankara, Thomas Sankara t-shirt. This is one of my favorite t-shirts. Thomas Sankara was a revolutionary leader of the country called Burkina Faso. Burkina Faso is in West Africa. It borders Ghana. I'm checking my map out right now. It's north of Ghana. So north of Ghana. So if you know where Ghana is in West Africa, on the Horn of Africa, Burkina Faso is just north of there. It also borders Cote d'Ivoire. Cote d'Ivoire, of course, is to the west of Ghana. I'm looking that way because I got a map of Africa on my wall right there that you can't see, actually. But yeah, Thomas Sankara was dope. He was thorough. And, he was a Pan-African and he wanted to be free. And he wanted his people to be free. He didn't just want himself to be free. Because if he wanted himself to be, I guess, free to an extent, he could have just, been a puppet leader and let the French just like give him bread. And then he could have just been a neo-colonial leader and been a millionaire and a multimillionaire, and lived in a mansion and whatever until he died and whatnot, and been under the protection of like France and the United States and a lot of other European nations and whatnot, while his people were getting exploited. But he took a stand and said, no, he wanted his people to be free, and he was a Pan-Africanist. He wanted the whole continent to be free and African people globally to be free. And in his writing, he talks about it. In his speeches, it's very evident. I got a couple of books here. This one is Thomas Sankara, An African Revolutionary by Ernest Harsh. You can check that out, grab that online somewhere or in a black bookstore. Go check a black bookstore first, or a black online bookstore. Thomas Sankara Speaks. Thomas Sankara Speaks, the Burkina Faso Revolution from 1983 to 1987. This is a bunch of his speeches. Also, this is a book of some more speeches. We Are Heirs of the World's Revolutions, Thomas Sankara, Speeches from the Burkina Faso Revolution, 1983 to 1987. So definitely check this brother out. I'm talking about him especially on this channel because you ain't going to hear about him in your public school. I almost guarantee you. I bet money. Or your charter school or your private school, unless maybe you're at an independent African-centered, private school. But 9 times out of 10, actually, I would say 98 times out of 100, you're not going to hear about Thomas Sankara, but you need to. And I'm telling you about him. So it's cool. Because that's what we do here on All This Math. You're going to get some math, but you're also going to get some culture and some history as well, because it's all interconnected. and it's part of hystematics. Hystematics is where we combine history and mathematics and history, either way you look at it. All right, so Thomas Sankara, remember the name. If you were unfamiliar with him, look him up. If you're a youth and you have you take a history class or a social studies class and you're looking for somebody to do a project on Thomas Sankara. I'm telling you, he was a thorough brother. He was so thorough the French had to assassinate him in 1987. You don't just assassinate people that's just weak nobodies. You don't do that, right? That's how thorough he was. All right. So, and some books are also mentioned. And if you need the titles, just rewind the video, run it back, and then pause, and you'll see all the titles. All right. Now let's get into the math. Like I said, frequency distribution table. We're trying to find the mean, the median, and the mode. There's a specific way we got to do this. We can't do it the typical way of finding mean, median, and mode when you know the specific data values. With the specific data values to find the mean, all you do is add up all the data values and divide by how many data values you got. And then you'll have the mean. To find the median, you put all the specific data values in order from either least to greatest or greatest to least. And then you look for the data value that's in the middle. It's in the middle. Now, if you have an odd number of data values, then you got a middle value, right? You have a single middle value. Like when people have 5 children, like I come from a family of 5 children. So there was a middle child, right? But if my mother and father had an additional child, and there had been 6 children, there would not have been one individual child. Like my sister, Sabira, she has 4 children. So she has no middle child per se. She has 2 middle children, right? So technically she doesn't have a middle child, right? So if you have a set of data where there are an even number of data values, you have to find the 2 middle values, and the 2 middle values, you would take the mean of the 2 middle values, and that would be the median. So there's one thing you do when you got an odd number of data values. There's something else you do when you got an even number of data values, right? Now, here, we can't do that. We got to do something different because we don't know the specific data values. We know the ranges. So, for example, the weight class, right? 120 to 139. We don't know how many people are exactly 120 pounds, exactly 138 pounds, exactly 131 pounds. We don't know. We just know that they're lumped in this group in here. That's all we know. So we got to do some different math to figure out this information. The mode is pretty straightforward. Once we find the frequency, we can tell what the mode is, because the mode is the weight class that has the highest frequency. And of course, the frequency is the amount of times that weight class is, that there are the number of data values in that weight class. That's what the frequency is, meaning how frequently we have a data value in that group. How frequently do we have a data value in that group? That's what frequency is. So I'm using the letter F to represent frequency. All right. So now I got to give you the information for frequency. We don't need to calculate anything for frequency. That's raw data. So, and I'm going to just use the information on my notes for this. So in the 120 to 139 weight class, we got a frequency of 6. All right. So you want to copy this down if you're working along with me. And after I write the frequencies down, if you want to do the work by yourself for practice, you could just pause the video and then rock out, find the mean, median, and mode, and then you can hit play to find out, if you have the same answers that I got. All right. Now, the 140 to 159 weight class, there were 8 people in that weight class. The 160 to 179 weight class, there were 12 people in that weight class. The 180 to 199 weight class, there were 7 people in there. The 200 to 220, there were 3 people in there. All right. Now, one thing we should do, now we got the frequency, in order to find the median, we're going to need the sum of the frequencies anyway, right? So we might as well find that now. So what I do is I write a line and I write sigma notation. That's not a good sigma, but sigma is a Greek letter which stands for the sum, right? We're going to add them all up. Just add them all up. 6 plus 8 is 14. 14 plus 12 is 26. 26 plus, you know what I'm going to do? This is 26. What if I did 7 plus 3 and I got 10? And then I did 26 plus 10 to get 36. That's easier than doing, in my opinion, that's easier than doing 26 plus 7 and then adding 3 to that. So, but these are just, you know, these are just some of the tricks we could do with mental math. When we understand those math fundamentals, you know, we can play with numbers. We can play with things and manipulate numbers and move them around, switch them up. We can do that, right? All right, now, next thing we're gonna find is called the cumulative frequency. Why is there an asterisk right here? Because this can be used to find the median once we calculate this, right? Now, cumulative frequency. Cumulative means the total of something, right? When something adds up, right? Cumulative. All right, so like when you say, okay, is the final exam cumulative, right? That means is everything from the semester going to be on the final exam? Sometimes the final exam is just a test, right? If you don't want to test, if your teacher doesn't want to give you a test on everything from the whole school year or everything from that semester, and they're just basically going to test you on the material you've covered since the last test, then that's not cumulative. But it's cumulative if you get tested on everything from the whole semester or everything from the whole school year. That's cumulative because it's everything. All right, so apply that here. So cumulative frequency of this weight class is 6, right? Now, the cumulative frequency of this weight class means it includes the smaller weight class plus this weight class. The smaller weight class plus this weight class. So that would be 6 plus 8, which is 14. And then this cumulative frequency is this weight class plus both of the smaller ones. This one plus the smaller ones. So we're doing 14 plus 12. That's 26. Then the cumulative frequency of this weight class is going to be this weight class plus the 3 smaller ones. So we adding up so you see the pattern, right? The next weight class you get to, you add that weight class plus all the ones before it or all the ones above it. So we do 26 plus the 7, which gives us 33. And then we're going to do for this weight class, it's going to be 33 plus the 3, which is 36. Now look at how these numbers match up. They should always match up because this is the sum total of all the frequencies, and the cumulative frequency should have a final value which is equal to all of the values. That's one way to check your work. All right, so that's our cumulative frequency. And again, why do we need this? We need the cumulative frequency so we can figure out the median. We need that for the median. All right, keep that in mind. Always know why you're doing all these things. All right, whenever you do math, know why you're doing it. Why am I figuring this out? Why do I care about this? Why am I adding this? Why am I multiplying this? Why is an important question. You should always be able to answer the question why. All right, now the midpoint. The midpoint of the weight class, right? In order to find that, use this formula, write it down in your notes, and then memorize it as soon as possible. Lower plus upper divided by 2. Lower plus upper divided by 2. So the lower value is 120 plus 139. And then you divide that by 2. Follow order of operations. 120 plus 139. You're going to have 159. And then 159 divided by 2 is going to be... No, it's not 159. I'm tripping. It's going to be 259. Yeah, it's going to be 259. 120 plus 139 is 259. And then divide that by 2. You're going to have 129.5. And then for this weight class, you're going to have a 140 plus 159, which is going to be 299. And then 299 divided by 2 is going to be 149.5. And you notice the pattern? You notice the pattern between the numbers developing, right? 160 plus 179 is going to be 339. Divide that by 2, you get 169.5. And then 180 plus 199 is going to be 379, I'm going to say. Yeah, like 379. And divide that by 2, and you get 189.5. 200 plus 220 is 420. 420 divided by 2 is 210. All right, so that's these are all your midpoints. These are the midpoints of the ranges. Now, why do we need the midpoints? Because the midpoint is included in this product, frequency times midpoint, frequency times midpoint. Now, what is this included in? This is included in the formula for the mean. Formula for the mean. So you want to find the mean? Cool. There's a formula for that. What's in the formula? Frequency times the midpoint, all those values added up. All the values added up, right? But in order to find frequency times the midpoint, first you got to know the midpoint. We already know the frequency is these numbers. We know the midpoints. Now we got to multiply them together. So first we're going to do 6 times 129.5. Use your calculator. When I did 6 times 129.5, I got 777. And then when I did 8 times 149.5, I got 1,196. Then when I did 12 times 169.5, I got 2,034. See, it's not difficult. It's tedious, but it ain't difficult. I mean, it's arithmetic. We just doing multiplication, right? And to get the midpoints, all we did was addition and division. We doing arithmetic. That's all we doing. And ain't nothing too crazy, all right? You got to know how to do it, though, and you got to take good notes, right? You got to know the steps, and you got to know why you're doing it, and you got to know what steps to use, though. But in terms of the math, we really just doing arithmetic, right? This is elementary school math that we're doing right now. So now to find the FM product of this weight class, we do 7 times 189.5, and we get 1,326.5. And then to find the product, the FM product of this weight class, we do 3 times 210, which is 630. Now, for this formula, we're going to need the sum of these values. So we draw a line, and when I add these up, my sum is, and I use the sigma, right? The backwards E, basically. Or is it? No, that is an E. That's an E. It's like a backwards 3. See, that's a 3, that's an E. Yeah. All right, so sigma, we got 5,963.5, right? Now, I can use this formula to find the mean. So this formula says the sum of the products of F and M, these are the products of F and M, this is the sum right here, divided by the sum of the frequencies, 36. So we plug these numbers in. 5,963.5 divided by 36. So make sure you always know where the numbers are coming from. Where they coming from? Why am I putting that there? Because this and this are the same thing. This and this are the same thing. So now we got 165.65, which is roughly, if we round, we're going to round this up to 166 pounds. So that's the mean weight. That's the mean weight out of these weight classes and out of the frequency of people that are in each of these weight classes. The mean weight is 166 pounds. All right, 166. So now we know the mean. So we're 1/3 of the way done. We still need to find the median and the mode. Now for the median, we're going to follow this formula, which is sigma of F divided by 2. And sigma of F, we see, is the sum of the frequencies. Add them all up, we get 36. So replace that numerator with 36, divide by 2, we get 18. Now, 18 is not the answer. We take this number, right? This is a very important number. And we go to the cumulative frequency column and we look for where 18 would fall. Now, 18 is not an actual weight. It's a position. It's a numerical position. If we were to take all the weights and assign the smallest weight a number of 1, and then the next weight a number of 2, the next highest weight would be the second one, the next highest weight would be the third one, the next highest weight would be the fourth one, the next highest weight would be the fifth one, and so on and so forth. We know that the 18th weight is the median. The 18th weight, whatever the 18th weight is, in order, is the median, the 18th weight. So our job is to look and find where the 18th weight would fall. Now I know weights 1 through 6 are here, so this is no good. I know weights 7 through 14 are in this range. So this range is no good because we're looking for the 18th weight. Now, this range right here goes from 15 to 26. 15 to 26. Now, how do I know that? How do I know it goes from 15 to 26? Because that might be a question that you're asking right now while you're watching this. I know that because from here to here, again, from here to here is weights 1 through 6. After 6 comes 7. So from here to here are weights 7 through 14, right? Because this is the upper limit. This number right here is the upper limit, right? Then after this group is 15. So, and this is the upper limit. So in this range is weights numbers 15 through 26, right? 15 through 26, because that's the numerical position of the weight. It's not the actual weight. It's the numerical position in terms of if you listed out all the weights from least to greatest, right? It's like people waiting in line. Everybody got a ticket. They got a number, like at the deli or wherever you be at when you get a ticket, you know, you waiting in line, right? Waiting on your turn. So the median value is in the 18th position. How do I know that? Because I use the formula, sigma F divided by 2. Where's the 18th position at? It's in this range. Why? Because this range has the group that has the positions of 15 through 26, and 18 is in that group. 18 is between 15 and 26. So since 18 is between 15 and 26, the median is 160 to 179. That is the median. The median is in this range right here, 160 to 179. That's the median. And that's how we figured it out. We used sigma frequency divided by 2. We found the numerical position, and then we go to the cumulative frequency column, and we find where that position is, which group it's in. It's not in the 1 through 6 group. It's not in the 7 through 14 group. It's not in the 27 through 33 group. It's not in the 34 through 36 group, right? It's in the 15 through 26 group. And again, how do I know it's 15 through 26? Because this group stops at 14. The next number after 14 is 15. And this group stops at 26. So it's in the 15 through 26 group because 18 is between 15 and 26. That's what you got to remember whenever you try to find the median with a frequency distribution table. These are the details. You got to remember these details. And the only way to remember details is by doing a lot of problems. You got to do a lot of problems. Now, the last thing, last but not least, the mode. The mode is the value that shows up the most popular value. So to find that, and like I said, this is probably the easiest. Go to the frequency column. Look for the number that is the biggest. 12 is the biggest. That means the largest amount of people are in this weight class from this sample of data that was taken. The largest amount of people are in this weight class, 160 to 179. 160 to 179. So that's the mode. The mode is also 160 to 179. And because it's a frequency distribution table, our mode is, our median and mode are ranges because we don't know the specific numerical values. Like, we don't know. We don't know. We don't know the specific numerical values. We just say 160 to 179. For the mean, because we use the midpoint, we come up with a specific value, right? But because we use the midpoint. All right. So that's that. But get some practice though. Get some practice. So get some practice so you can memorize these formulas, these little formulas that are used to, be a part of larger formulas, and understand the concept. Get some practice so you can know the concept of what you're doing when you're finding the mean, the median, and the mode, and so that you can talk intelligently about it. Because you want to be able to talk intelligently about what you're doing. All right. So get some practice. Ask your teacher, your professor, or whomever, or go online and just look up some practice problems on finding the mean, median, and mode with frequency distribution tables. Get some practice. Make sure you do your research on Thomas Sankara, because that brother was thorough. Make sure you do some research on him. And I'll see you on the next video. Peace.